Welcome back, everybody. I appreciate your spending a little bit of time with us this afternoon. These iLogic webcasts are quite popular, and we'll spend as much time as we can at the end of the webcast with the Q&A. So write those down and let us know what questions you have. It's just a way of intros. I manage the professional services team throughout North America. On my team is Randy, who does a lot of work with development, especially with the iLogic side of things, helping folks with configurators and just whatever automation that we can help people be more productive with. So he'll be joining us shortly as soon as we get some of this, intros out of the way, all right? So first of all, a little bit about my company. If you're not already aware, IMAGINiT, which Randy and I and Cassie all work for, are a part of this umbrella team called RAND Worldwide that include RAND 3D and Ascent. Ascent develops all the courseware for all kinds of CAD systems and engineering technology that typically, if you bought some courseware, you probably bought it from Ascent. In reality, bought it from RAND Worldwide and contributed to IMAGINiT. So it leads to the fact that we're company's quite broad with a lot of experience, a lot of bandwidth to help folks do a lot of different things. And I said a lot. There's some push buttons here. You know what, Cassie, I forgot to get an updated map because it just dawned on me that some recent acquisitions out on the West Coast are not on this map. But it's good enough for now to illustrate that we are present all over the place. Hopefully one of those push buttons is near you. And even if it's not, I mean, there are lots of good ways that we can communicate and talk, just like we're doing now, to get your situations figured out and under control. More importantly, what this map illustrates is our ability to not have to be pigeonholed in a specific expertise. Folks who might approach us down in the Texas area and have questions about mining and the coal industry or the oil industry and all that kind of stuff, we can always utilize folks in Western Canada who have those specialties. Folks on the West Coast and the East Coast talk a lot about shipyard stuff happening there. Right? So lots of bandwidth. In other words, if one of our technical people doesn't have an expertise in a particular area, I'll bet you there's somebody on one of these push pans we can talk to that will have that expertise. So enough about the intro stuff. I want to introduce Randy. We're going to talk a little bit about some of the techniques that we can use with iLogic to help you with what we call model descriptions. Model description meaning everything from a typical 2D technical drawing that you might create from a model or an assembly, or because the world is moving and moving away from the traditional 2D technical drawing, we're going to talk about some other things too that you might find interesting in describing a model in the 3D realm as well. We see a lot of this interest all over the country, and we struggle with 2D technical drawings because people aren't any good at interpreting. We hire people off the street, and it takes them a long time to figure out what a model looks like based on a technical drawing. So what can we do? And a lot of it is based on this model definition format that Autodesk is promoting, that a lot of people are promoting, and we see a lot of interest in companies saying we want to move completely away from it. We want to describe our model both geometrically and as a tolerance values and all those kind of stuff with model-based definitions. So we'll take a little quick peek at how we can automate some of that stuff for you as well. So Randy, I will see if I can't get you over to the presenter. And you should be able to share your screen, sir.
Yep.
I will go on mute and let you have the floor. Thanks much.
All righty. Thank you, sir. Either Carl or Cassie, if you can let me know that you can see my screen all right.
Yep,
yes,
looking good.
Sounds good. So my name is Randy Mabery. I'm an application expert on the Manufacturing Solutions Division team, specifically the South team. I'm coming to you from warm and humid Raleigh, North Carolina today. So I hope the weather is a little bit better wherever you guys are at. As Carl said, we're going to talk about ways of describing our models. Traditionally, we're talking about 2D drawings, 2D technical drawings, like Carl stated. but again, we're also going to take a look at model-based definition. So what you see on your screen right here is a very simple part, just a spacer block. It's got a single tapped hole in it. I do want to point out that I'm using what's called the named geometry inside of here. So if I go switch over to my geometry tab, we'll see some edges and some faces here. I'll go ahead and turn on their visibility so that we can see them out on the screen. And this is added with the new 2019 assign name command. Okay, if you guys have Inventor 2019, I can select on a face or an edge or whatever entity I want, and then using my right-click and go down to my contextual menu is the new command called assign name. And what this actually does is create an attribute and assigns that attribute to that entity. Okay, so in this case, I'm going to call this bottom face bottom. Okay, I hit OK, and it'll show up over here in my geometry tab of my iLogic browser. So what we use those for is to go back and find geometry that I want to work with later on. Okay? In this case, I've got an edge marked here for edge length. I've got edge width marked. I've got an edge thickness, and that's working directly off of that geometry. So there is an attribute tied to those faces or those edges that then the iLogic code can go back and find. Okay. You also notice that I have some work points listed out inside of my model browser. We use those as well when we go back and create the 2D drawing. Okay. So the first thing I want to do is turn back off this geometry. Switch back over to my Global Forms tab. I just stuck some of my rules out here on my Global Forms tab just to make it easy for the WebEx here so I can easily create these. So I'm going to go ahead and run my 2D drawing first. Again, making a traditional 2D technical drawing. So I'll give you a quick overview of what's happening here is the code goes in and finds a parameter inside of my model. In this case, I'm defining the width parameter as how I want to control the scale of my drawing. Okay, so it finds out it's a 1/2 inch. It takes that scale and calculates, or I'm sorry, it takes that parameter and calculates what scale to place that first view on. I'm going out and grabbing my standard .dwg template. Again, I'm not opening up an existing drawing. I'm making this straight from scratch. I've predetermined that this is a sheet or a B size drawing based upon what size this part is. Okay, so that's something I know in the back of my head as I'm doing this code. This is probably always going to be a B size sheet of paper. Okay. I'll talk about handling those other cases here in just a minute. So it throws up the base view, creates a projected view, goes through and adds center lines. You notice there's center lines turned on here in both the parallel and normal to view modes. I'm inserting my dimensions. Okay. You'll notice here on the front view, I've got some locating dimensions for locating my hole, and then I've also got some stock dimensions. Those are using 2 different types of dim styles. That's something I can control with code. In the hole locating, I'm using 3 place decimals. And then in the rough cut or the stock dimensions listed there, as well as in the overall length, I'm using a fractional. Okay, those are just different dimension styles that are listed out inside of my Styles and Standards editor in my drawing. And I'm just calling out whichever one depending upon my tolerance block that's required. Okay. I'm also inserting the whole note. So this whole note's being inserted, and there's a general note down I'm putting down in the bottom left corner. Okay. These annotations, these dimensions, there's nothing special about them, even though I'm creating those with code. If I go inside of here and edit this dimension, we get the regular edit dimension dialog box, and we see the STK text that I applied to the end of it. That just stands for stock. I'm buying a piece of 1/4 by 1/2 stock, and I'm saw cutting it off to 1 1/4 inches long. Okay. Same thing with the whole note. Nothing special about this whole note. It's a standard whole note. It is tied back to the geometry. So if I go back to my simple part drawing, or I'm sorry, my simple part, I'll open up a quick little form here that I made, just throwing on some dimensions. I can change that length to 1 1/2 inches. and then shift my hole over just a tad, and then go back to my drawing again, and we'll see that it updates. It's all associates still there. Okay. You'll notice I'm not doing anything in this case about arranging dimensions. That 375, should be shifted over a little bit. This 1.5 inches should be shifted over a little bit. But all that is available through the code. Okay. So the positive, the plus side of creating drawings this way, obviously no need to manually create this drawing. This works great for configurators when things are really well known. Okay, this is a configurable part. That overall length might change. Maybe my hole location might change. So I need a new set of prints every time. So allow the code to go create those for you. Okay. It's still highly recommended that someone puts a pair of eyes on these. Okay. You never know what's going to happen. Someone should always be checking every drawing, no matter what, if it's manually created or if it's created by the code. Okay. So some downsides to creating drawings like this, you have to know everything that's going to be annotated. Okay. In this case, this is a very simple block. And if the only variations might be the length and the width and the thickness, sometimes I might have that topped hole, sometimes I might not. The hole size could possibly change. Okay. I have to make accommodations for all of those instances when I'm writing out the code for this drawing. Okay. In the case when there isn't a hole, obviously wouldn't need this 1/8 dimension or this 3/8 dimension up here, right? Those would be gone. So I would space this 1/2 inch dimension off differently, and I would space that 1/4 inch dimension off differently. Obviously, I wouldn't have to throw this whole node on as well. Okay. So I have to understand all the possibilities that might happen with that and make accommodations for those. Okay. If you think about the general steps that you might take when you're placing a dimension, right? If I'm manually creating these dimensions, I know I'm going to place a 3/8 dimension to locate that hole, and then I know the next one's only going to be the width dimension. So I'm determining the location of this as I'm placing it, and I'm determining the location of this one as I'm placing it. The code is going to have to know all of that as well, right? More complex drawings, right? If you get into assemblies, getting to much more complex parts. If you're talking about moving views, sometimes I might have to have a detail view, sometimes I don't. My section view might have to move around based upon whatever my section view is trying to describe out of my assembly or outside of my part. Throwing on balloons, etc. All of this has to be really thought out before you start building up your code. Okay. So that's the positive and negatives of something like that in a traditional 2D technical drawing. I'm going to switch back over to my simple part here, and let me shift back over my hole just for fun. Okay. So we can also create what's called model-based definition. It's really been taking off momentum in the last few years. It's a way of describing our model inside the 3D workspace. If you go take a look at your annotate command inside of a part in Inventor, we can see the 3D annotation tools, my geometric annotation tools, I got some general annotation tools, and then some notes. Model-based definition was first introduced in part mode only in Inventor 2018. And then the 2018.1 update, they expanded it and gave us some tools inside of the assembly tool, or inside of the assembly environment. Okay. So in the same case here, I'm still going to be looking at that named geometry that we saw before. I still want to go back and I grab an edge or I grab a face based upon whatever type of annotation I'm trying to put on. Okay. If I run my simple part annotation rule here, I'm pretty much creating the same dimensions that I saw in that simple 2D technical drawing. So what I'm doing here is, again, I'm going back and finding those named geometries, those attributed geometries, finding an annotation plane to create it upon, and then spacing that dimension away from my part some certain distance. Okay, so I've got my length and my width, thickness, the whole locating dimensions, and then as well as a whole note. Okay. Nothing really different about how these are created. You know, if I created a standard general annotation with my dimension tool, I'm going to go ahead and click that edge. Right. If you haven't created a 3D annotation in a model, I have an annotation plane that I can assign that to. Right. I'm simply hitting space bar on my keyboard there to flip it back and forth between them. But in essence, it's the same process that I'm doing with the automation tool. Okay. Nothing special about these. Let me get rid of this box. There we go. So if I double click and edit that 3D annotation tool, you know, I still have my standard. I can change the precision of this guy, change it from a default to a basic to a reference, etc., changing the tolerancing. One of the drawbacks to creating this with code is I cannot, as of the 2019 version, I cannot change the tolerance of this to, say, a basic dimension. Okay, that would have to be something I would come in manually after creating it and doing that. Okay, but again, you wouldn't be able to tell the difference between what I was creating manually versus what I was creating with code as far as the 3D annotations. Okay, so some of the things that are supported through iLogic, or more importantly through the Inventor API, are what's in the general annotation panel. So dimensions, whole threads, and notes, and surface texture symbols. And then what's in the notes panel, leaders, general notes, and general profiles. What I cannot do at this point is GD&T. I can kind of get around some of that, and I'll show that in a bit. But generally, anything in the geometric annotation, again, as of the 2019 release of Inventor, which is what I'm running here, it is not yet supported through the API. Okay. I'm going to go ahead and clean up this model by hitting my delete model annotation rule there. I'm going to switch over to another part here, something a little bit more complex. It's simply a motor plate. It's got some tapped holes in it, and then I'm machining a channel, a face down on the bottom side. Okay. So again, I can create a 2D drawing with this. Going to see a lot of the same things that we saw in the last example, although in this case I'm throwing in some additional entities. I'm going to throw in some center lines, as well as a surface texture symbol, and then a leader note or a leader. So again, I'm creating various dimensions based upon what has to be dimensioned, throwing in a whole note. What we see here in addition are the center lines. Okay, that is a pattern down in my parts. Go take a look at the piece part there. There is a rectangular pattern of the holes, and that is showing up as center lines in my 2D drawing. And again, what I have here new is a surface texture symbol, and then a leader. Again, nothing special about this guy. If I go through and edit it, you won't be able to tell a difference between this surface texture symbol or something that I manually created. Same thing with the leader. Okay, there's my format text dialog box for that leader. Okay. And again, I'm working off of named geometry, whether those geometry are faces or images. Apologize about that. All right, so let me switch back to my motor plate part here, and we'll look at some annotations. Okay, some 3D model-based definitions. So again, I'm creating dimensions, as well as surface texture symbols, and then a general leader. And again, I have the same control here. If I go back and edit the surface texture symbol, I can modify whatever I need to modify about it. And then my general leader note. Okay. One thing I will say about the general leaders, if you do end up creating those inside of Inventor with code as a 3D annotation, there is a slight weird thing going on with it. You do have to call out the font specifically. If you do not call out the font, and I go back and try to edit this thing, it gives me a little message that says, hey, the expected font of blank isn't available. everything still works. It's just a weird little kind of a bug that's in the system at this point in time. Okay. So again, nothing special about those 3D annotations, whether they be the dimensions or they be the surface texture symbols or the leaders. Okay. I'm going to switch over to a little part here for some GD&T. As I mentioned earlier, I do not have the ability to create tolerance features. Okay, I cannot build compound tolerance features. I can't build anything out of this guy, but I can kind of fake some of it. So if I run the GD and annotations rule here, you will notice that I've applied a datum down here to this face. I'm saying this top face is flatness within 30 thousandths. I've got some faces that are parallel and perpendicular to A within 10. The drawback here is that I can't go back and edit these at this point. Okay, I can create them with code. I can apply them to a face. I can apply what appears to be a feature control frame. Even shows up over in my annotations. But what I can't do with it at that point is edit it. Okay, I expect at some point here in the next few releases that will be further exposed in the API, as well as if I was trying to create a tolerance feature using the standard tools. You know, again, this is not something that I can do with the API at this point in time. Okay. Let me go ahead and get rid of that guy. Delete that one that I just created and get rid of the Tolerance Advisor tool. I'll go through and delete those model annotations. Okay. Let me switch over to an assembly mode here. And I created a very simple assembly here with some brackets, wheel and some axles and some socket head cap screws. I'm going to take a look at the 3D annotations here first. So if I go over to my Annotate tab in the assembly environment, assemblies do not have GD&T possibilities. So the only thing I have at this point is general annotation and then notes. Okay. So if I run that wheel bracket annotations rule, so all I'm simply doing here is I threw some width and dimensions, or width and length dimensions on here, and then I'm creating some leaders. I go take a look at my annotation here. Some leader text that kind of works as balloons in this in an assembly mode. Okay. Again, nothing special about these. If I go back through and edit them, I'm simply going to open up my text editor so I can modify what that text is. Would be the same as if I dropped a standard leader text. Okay, and then I've also got a general note up in the upper left corner. Let me switch my priority here to an annotation priority. So I can go back through and edit that guy. Again, I can have the selection or control over what quadrant of my screen that those show up in, and nothing different from those is if I created a general note using this tool and then specifying what quadrant, or excuse me, what quadrant those are supposed to go into. Okay. So again, with model-based definition, my limitations in the assembly is only creating dimensions, whole thread notes, surface texture symbols, leaders, and then general notes. Okay. Something else that's a little odd that you might beat your head over is I cannot delete these annotation objects in an assembly as I can inside of the part. Switch back over to my motor plate. I still have these here. I made a simple rule here for deleting model annotations, and all it's doing is looping through all of the dimensions or all of the leaders, all of the general notes that I might have on this drawing or on this model, and it simply deletes them. Going back to my wheel bracket, excuse me, I still got the annotations there, but I cannot delete them the same way. For some silly reason, that method is not supported on an object inside of an assembly. So if you ever get to that point, again, at least in the 2019 version, I would have to delete those manually. Okay. I'm going to try my 2D drawing environment here. I was having something go really wonky right before this, and it still looks like it's wonky. So I can create a 2D drawing, and then we can create balloons, and we can create parts lists. And for some reason, I'm not exactly sure what happened between yesterday and today, but that bit that's applying the parts list is wonking out on me at the time being. So again, some of the limitations with a 2D drawing with code is I cannot collect balloons. Okay, so if I was going to go back through and annotate that, something you do in a more traditional method, if I wanted to throw that axle inside of here as well, is to attach a balloon for that axle. That's something that still is not exposed in the Inventor API. As of the 2019 version, I'd have to manually create each one of those. Again, you could always come back and attach them, collect them, move them around as you wish afterwards, but not something I can do straight off the bat with the code. So, okay. That's it for my my show there.
All right. Very well done. Very well done, Randy. While you're putting the presentation mode back over on me, I'll get wrapped up here. I think, you know, this is kind of an academic exercise, an academic display on what's possible using automation to describe a model. It doesn't fit for every scenario because a lot of times, you know, a drawing is very unique, and it you know, calls for a specific dimension methodology to make things look like they're supposed to look, all that kind of good stuff. So it, you know, it may be better for you guys to think about, well, if we're going to create 2D technical drawings, maybe we just use some common rules that we know that's just going to create the views for us. Just slap the views up really quickly, maybe some common dimensions, or maybe even charted dimensions or something like that. It's always different. Just keep in mind that it's really tricky when we're working with clients describing what looks good. What looks good for one client looks good, doesn't look well, doesn't look right for another client. So it gets kind of tricky, and you can get down in the weeds pretty quickly when you're trying to describe 2D technical drawings with dimensions and models and all that kind of stuff.
Yeah, Carl, another thing, you know, about that spacer block, that very simple spacer block. Something like that, if the only thing changing in that is length and width, then go ahead and make a drawing of that as part of your template. You're going to have to go through and clean up some dimensions, move a dimension from one, you know, shift it over to the left and move it up and down based upon what happened when the part updated. But if you're not worrying about certain dimensions being there at times and not, views being there at times and not, then sometimes it makes much more sense to have just a simple drawing already made up that I don't have to worry about automating.
Mm-hmm. Yeah, I think it's the utopia. It's the kind of the thing that everybody on the surface really would like to see. I just should be able to click an easy button and have it create drawings for me. Right. Well, without realizing how much thought goes into creating a drawing, sometimes that's a more difficult task than what you think it might be. But we also expose some of the alternative new wave, if you will, methods for describing a drawing, and that's with the model-based definition, which is really compelling to some people for not having to worry about having a separate drawing that describes the model in 2D, and B, a methodology that anybody can look at that model, spin it around, and understand the dimensions and tolerances behind what the model's supposed to look like. So those are very, very compelling methodologies, and again, automation may play a part in helping you out with that as well. So while Cassie is gathering questions for us, I just did want to wrap up on where we go from here. If you're interested in discussing this further, please give us a note, give us a shout. Sometimes we get things kicked off with a discovery session on, okay, exactly what do you want to automate and how do you want to automate it? We move to an optimization stage where my professional services team, myself and the guys that work on our squad will help you with something usually some automation or some technical training, or maybe just a support plan to keep you moving, and then a productivity plan to keep you moving forward. So it involves either additional training or ongoing support. It's kind of the loop. It's kind of the way our world works in helping support our clients is with our best workflows and best practices, and really best in industry expertise from the folks on my team. Our services not only involve the process automation and software development like Randy's involved in, but all sorts of things, including just general consulting. Data management and file management is huge for us. You work with Fusion Lifecycle for process automation, even simulation consulting and outsourcing. So lots of stuff like that as part of our term. As part of our team is also our learning and training. We do all kinds of education. You know, we always say training, Cass. Maybe we ought to change that. We train a dog, but people learn. So, but whether it's in person, live online, custom classes, we come to you, you come to us. A blended methodology of having an instructor help you out for a bit, and then turn you loose, let you work on your own, and then come circle back around later. There's all kinds of ways for you guys to become the subject matter experts that you need to be to keep your head on a swivel in today's world of fast-moving technology and fast-moving workflows. Our relationship with Autodesk, of course, we're their largest authorized training center. We're their largest and leading provider of software products. In fact, they're our largest customer, believe it or not. We do a lot of work for Autodesk and their consulting services and helping their clients directly as well. Our performance is proven in our fact that we have an implementation methodology that we refer to called Take Aim, which is just as a workflow that we've learned over time works best for most clients to get them up and running quickly with the shortest ROI. Our Productivity Now portal is our methodology for supporting you guys after the fact so that you have a dedicated help desk. You're not trying to chase down a technical person somewhere, hoping he's not training or on vacation or on sick leave or out running at 4 o'clock in the morning. And then, of course, we're very, very proud of the fact that we are award-winning as far as our relationship with our clients as measured by Autodesk. They are very keen that we take care of our folks, and we are top-rated in our customer satisfaction. That makes me very proud that our guys are doing what they're supposed to be doing for our clients. So, Cassie, before we wrap up, were there a couple of questions posted or anything from the audience we can address?